This lesson will be solving right triangles, which means to find all the missing angles and all the missing sides. So let's take a look. We'll be using some trig, some other stuff we've learned. So the first thing we learn is a new one, the inverse trigonometric ratios. Kind of the opposite of the regular trig ratios, and you'll see why. In your notes it shows it like this. The inverse sign, kind of give you a definition of it, is like this. If sine of an angle A equals y, and this y is usually a fraction. I think it's confusing written like this. I'll show you it a little different way here in a second. Then the inverse sign, we put in that ratio and it will equal the angle, and our calculator has this. Here's a better way of writing this. Let's look down here. Now when we're using the regular sine function, the sine of an angle, we put the angle measure here, especially if we were using the calculator, or if we were just setting up the equation to solve it for a missing side. We'd have the sine of an angle equals what? The side opposite in this picture. Opposite angle A is this side CB, over the hypotenuse, which is the side BA. And we'd set this up, and usually one of these sides would be missing, and we'd solve for it. Okay, and we know this measure of this angle A, you know, maybe it was 50 degrees or whatever. We might have the sine of 50 degrees equals this side over this side. And we'd solve for that missing side. Now here is the inverse sign, is written like this, sine with a little, looks like a -1 power, but it means inverse sign. It is on top of the sign on your calculator. Has a little sign with a little -1, looks like power. What it does, we reverse these. Instead of inputting the angle like in the regular sign, we input the ratio or the fraction into the calculator. And what it puts out is the angle measure. Okay? So we'll see some examples of this. This is how they differ. This one we put in the angle into the calculator, we get out the fraction. You know, they usually divide it out on the calculator and gives us a decimal value. Whereas the inverse, we put in the fraction, the ratio of the two sides we're looking at, and the calculator will give us out the angle. Let's take a peek at this. So this example is not on your paper. I just wanted to show you a little bit how this works. I've set up a 30, 60, 90 degree triangle. We've studied those special right triangles. So here's my 30. So opposite this 30 was the, you know, the x side, and then I know the hypotenuse is the 2x side, so it should be twice as big. So I set it up, this side's 4 and this side's twice as big, 8. There's my 30, 60, 90. So if we didn't know these sides, you know, we'd put in the calculator the sine of 30 degrees. What does it equal? Well, we know the ratios for sine is opposite over hypotenuse. So I put the opposite in the hypotenuse. So according to this picture, you know, the sine of 30 degrees should equal 4 over 8, which is 0.5, or 1/2. And yes, with your calculator, if you put that in there, if you turn it on, clear it, make sure we're doing trig now, make sure you're in degrees. I'll check mine. Yeah, I'm in degrees here. And I go ahead and put the sine of, again, 30 degrees. It should come out the same as this thing. Should come out to 1/2 or 0.5 as a decimal. You know, the calculator gives us the decimal value, not the fraction. They divide it out. Okay, 0.5. Now to see how the inverse sign works. Okay, the inverse sign, we're going to take these same two sides, opposite and hypotenuse, which again is sine. You know, so we're going to use the inverse sign since we're using opposite and hypotenuse. So when I put in the inverse sign, so you hit the second button and then the sign button, you should see the little -1 there. And then now we put in the ratio into it of those sides, opposite, which is 4, divided by the hypotenuse, which is 8. And it should spit out the angle. We already know the angle is 30 degrees. Let's see if we're right. And there it is. So the one, we put in the angle, we get out the ratio, the fraction as a decimal value. The other one, when we put in the ratio of sides into the inverse, we get out the angle measure. Okay, that's how easy it is to solve for an angle measure. We got the two sides. So let's take a look at back to your notes here. Back to your notes, it's just showing you how to set them up. So inverse sine, how would we set it up? Well, we're putting in the ratio of which sides. Well, for sine, it's opposite. So we're dealing with angle A over here. They're showing you, they're trying to find the measure of angle A. So with respect to angle A here, of course, this side over here is opposite. Sorry for the writing. Of course, here's the hypotenuse. So this is adjacent, ADJ. So sine is opposite, side BC, over what? Hypotenuse, which is side BA. The inverse cosine, what would we put in there? We'd put the adjacent side over which one? Cosine or inverse cosine is adjacent over hypotenuse, so BA here. And then tangent, just, you use these regular notes, okay? The only difference is instead of the sides being over here, they're over here. We're putting them into the inverse ones, but they're the same sides. Tangent is opposite, which is BC. We're still dealing with angle A here. So opposite angle A is BC over what? Adjacent. Keep those definitions handy for the trig functions. It would be opposite over the adjacent side, which is side AC or CA. You can call it either way. So that's what we wanted here, just to realize which sides to put in. The only difference is we're putting them into the function because it's the inverse function and getting out the angle. Okay, there's three different ways to solve for the measure of angle A. We could have used the inverse sine, the inverse cosine, inverse tangent. It depends which two sides you know. We got to have both sides now to solve for the angle. Can't be missing one when we're solving for an angle. So you try that here, example 1, same type of thing. If we're trying to figure out the measure of angle A here, so with respect to angle A, again, you would start by labeling them. There's the opposite side. There is the hypotenuse. There's the adjacent. And so if we're looking for angle A and using inverse sine, we've got to have opposite and hypotenuse. The opposite goes on top, which is side SH, and the hypotenuse goes on the bottom. If we were trying to solve for angle A using inverse tangent, tangent is opposite over adjacent, so the opposite side is SH, and the adjacent side is SA. And if we were using inverse cosine, it'd be the adjacent side, SA, over the hypotenuse, AJ. Again, where do I get these? Opposite and adjacent. It's from the regular trig function definition. Cosine is opposite over hypotenuse. Tangent is opposite over adjacent. All we're doing now is putting that ratio into the inverse function. It's on the other side of the equation now. So you go ahead and try the quick check. If you want me to check them out, I'll do those. I don't have anything set up on the computer right now, so just call me over and I'll take a peek at it. Okay, do that quick check on paper. After you've done the quick check, we look at example 2 here. Now we're actually going to solve our right triangle and find all the missing pieces. Well, we've got all three sides here, so we're just going to find the missing angles. So we'll start off with angle D. So to find the angles, we set up an inverse trig function. So we're going to find angle D. Since we have all the sides, we could use any of the trig functions you want. I think I got boring, and I'm going to use the inverse sine. Okay, so here's angle D. So I know in sine, even the inverse sine, I need opposite. So opposite of angle D is 21 over hypotenuse, which is 29 here. Here's the hypotenuse. So if I put this into the calculator, I'm going to get the measure of angle D. So we go back to our calculator here. Let me turn it on. So again, I've set it up with inverse sine. I could have used any three of them since I know all the sides. So inverse, hit the second button and then the sine, and make sure you see the little negative one there. And it's 21 divided by 29. 21 divided by 29. I'm going to close that parentheses there. And so we're going to round this to the nearest degree. It would be 46. Since that 3 is next, it doesn't round up to 47. So we're going to round that to the nearest degree is 46 degrees. Okay. and that'll go in your answer blank there. So now to find, there's two ways to find the last angle. So we know this angle D is 46 degrees. I'm going to show you first again using these inverse trig functions. So our other angle is F. So for angle F, I'm going to get boring again. With respect to angle S, this is the side opposite. And of course, this is the hypotenuse. So I'm going to use sine again and use these two sides here, opposite, angle F, and hypotenuse. I could have used something else. I could have used tangent, cosine, any of them, since I know all the sides. So sine again is the opposite side. Opposite angle F is 20 over the hypotenuse, which is 29, will equal angle F, the inverse sine of this. We input this into the inverse sine and we get out the measure of the angle. So we just take our calculator again. Inverse sine of 20 divided by 29. And we get about 43.6. Since it's 0.6, we'll round this up to the nearest degree, would be 44 degrees. Now, we didn't have to use the inverse sine for this last one. We could have used the fact that since we knew two angles in this triangle, they all three have to add up to 180. You could have done this last angle this way. Okay, I just wanted to show you inverse functions again. But we could have just taken 180 degrees. The measure of angle F would equal 180, all of them added up, minus the ones we know. We know there's one that's 90 degrees right here, minus the other one we know is 46. If we take 180 minus this, we'd get the same answer, 44 degrees for angle F. So angle D was 46, and angle F was 44. Take a look at your quick check, see if you can set it up. Call me over when you get those answers. I will double check it for you. And now I'll go into the last example. Call me over, try the quick check, see if you need any help. Example 3, we've got, again, find all the missing pieces. They give us this side and one angle. So we're going to find this other angle G right here and with these two sides. So I'm going to do angle G the easy way. You know, we couldn't even use inverse functions right now because we don't even know two sides. But since we know these two angles, we can subtract them from 180 and see what angle G is. Okay, so angle G will equal 180 minus the 90 degree angle and minus that 55 degree angle, which equals 35 degrees. Okay, so now we've got the two angles. We'll go ahead and solve for this hypotenuse we're missing and this side right here. So I'm going to go ahead and do them with respect to this 55 degree angle. So here we have opposite. Here we have hypotenuse. And adjacent is this y side. So I just gave them names here so we can set up an equation to solve for x and y. So first I'll solve for x. And so I know from our trig functions before, solving for missing sides, I need to use this side since I'm solving for it, and one I know, 15. So opposite and hypotenuse, that's sine. So the sine of the angle, 55 degrees, equals the ratio. So we're using the regular trig function, solves for sides. The inverse solves for angles. So the opposite side is 15, the hypotenuse is x. And remember, we set it up as a proportion and cross multiply. So this side, x side first, x times the sine of 55, we write like this with the x out in front. This means multiplying, x times that little number, sine of 55 degrees is a little decimal number. And the other cross product is 1 times 15, or 15. So to get rid of this sine of 55 and get x by itself, we divide by that number, sine of 55 degrees. And so we put it in our calculator. This cancels out over here and leaves us with x. 15 divided by the sine of 55 degrees. Make sure you're in degrees. And that rounds to about 18.3. Now we know this other side right here is 18.3. I'm going to solve for the last side using a trigonometry equation, a trig equation again, but it was possible to get a close enough answer by using Pythagorean's theorem, a squared plus b squared equals c squared. But I'm going to continue with trig. There's different ways to solve these. So to solve for this y side, I still got the 55-degree angle here. I'm going to use the exact number we knew, 15, and the y side, the adjacent. Adjacent and opposite is tangent. So the tangent of 55 equals the side opposite over the side adjacent, which is y. So again, we're going to set it up and cross multiply. So y times the tangent of 55 degrees is 1 cross product. And the other one, 1 times 15 is 15. So we solve it similar by dividing by this trig function right here and getting the variable by itself. Divide by tangent of 55 degrees. And we get approximately 10.5 for that side. Okay, so check it with your calculator. That's it for the examples. I'd like you to go ahead and try the quick check. Round that to the nearest tenth, call me over, and then we'll take a look at some practice problems. Good work. Have a good day.